Good afternoon. Today discuss about control strategies of DC to DC converter. So control of DC motor due to the change of the firing pulse. So DC to DC converter. So duty cycle is equal to T on upon T. Are you? No. So control of DC motor is three method. First is a pulse width modulation, that means constant frequency system. Second, variable frequency system, and third is current limit. So constant frequency system constant frequency system, that means in a duty cycle the ratio of T1 time to the total time. So the time T is constant, so the time T is equal to 1 upon F, that means frequency. So time T is constant, that means frequency is constant due to the change of the time T1 time, So in buck converter, as you study, in buck converter output voltage is equal to Vs into T on T. That means T is constant, that means frequency is constant due to the change of T1 time. So T1 time is changed, that means the supply voltage is constant. For example, 50 volt. And T1 is duty cycle 50%. That means 0.5 into 15. That means output generation of the output voltage 7.5. Constant frequency system is called the frequency is constant. That means time period is constant due to the change of T1 time in pulse width. So therefore, control of the output voltage in boost converter, buck converter. For example, so the waveform time period 75 duty cycle, that means T1 and T. This is T1 time is 75%, T1 time 25%, T1 time 75%. Case 1, that means duty cycle alpha is equal to 75%. Similarly, PWM 50%. T1 time 50%, T of time 50%, T1 time 50%, T of time 50%. So this is T1 time, T off time, and total time T. The duty cycle is 50%. So in this figure, 25% T1, 70% off, T1 and off. That means T on and T off. That means duty cycle 25%. So the output voltage equation, the time T is constant, that means frequency is constant. Due to the change of T1 time, the control of the DC voltage in buck converter. So for example, 75% duty cycle, that means T1 time is 75%, T of time 25%. So the generation of the output voltage is 75% of the input voltage. Similarly, duty cycle 50%, that means T1 time is 50%, but T time is constant. So in figure, in case 1, duty case 2, case 3, total time constant is constant. but due to the change of T1 time, 75%, 50%, 25%. So therefore output voltage is controlled in a buck converter. Similarly, case 2, variable frequency system. So variable frequency system, so duty cycle alpha is equal to T1 upon T. Are you? No. So T1 time is constant due to the change of the time, that means due to the change of the frequency. So duty cycle is changed, that means the output voltage is controlled on a DC to DC buck converter. So case 3, so this waveform, duty cycle T1 50%, duty cycle alpha T1 is a 50%. T1 50, T off 50% of T1 plus T off, that means total time period. So similarly, duty cycle is 50%, alpha duty cycle is 50%. Case 3, alpha is 50%. So in this case, this is total time period T, this is total time period T, similarly total time period T. So therefore change T time is changed, similarly frequency is changed. So therefore the T1 is constant, time period T is changed, that means duties. So therefore the T is changed, that means T is increased, that means the frequency is decreased. Frequency is decreased, that means the output voltage is decreased. Similar frequency is increased, the output voltage is increased. So therefore frequency is high to low, that means output voltage high to low. Third condition, current limit. So in buck converter, switch connect to the freewheeling diode, connect to the inductor. So this waveform this is VG and current IL. So when applied DC supply voltage, connect to the switch, connect RL load, connect to the freewheeling diode. So when applied the gate pulse 0 to T by 2, at that time switch is conduct, at that time freewheeling diode is turned off. When applied the supply voltage, inductor is store of the energy. So inductor current is linearly increased at minimum to maximum. Similarly, when the gate pulse is removed, at that time freewheeling diode is conducted, the RL load is discharged. So therefore output voltage is 0. So therefore inductive current maximum to the minimum. So when increase of the inductor, so therefore the charging current and discharging current is increased. So the control of the DC voltage is DC to DC buck converter.